Energy and matter, flows, cycles, and conservation is the fifth cross-cutting concept for the K-12 Science Framework for Education. This presentation will teach about the concept focusing on how to integrate NAEP questions into lessons to teach the cross-cutting concepts. The fifth cross-cutting concept focuses on what types and how energy and matter are added to different systems. Tracking fluxes of energy and matter into, out of, and within systems helps one understand the system's possibilities and limitations. Teaching cross-cutting concept number 5 encourages students to develop critical thinking skills to identify and observe energy and matter in ways that might not be obvious or explicit at first. The ability to examine, characterize, and model the transfers and cycles of matter and energy is a tool that students can use across virtually all areas of science and engineering. National Assessment of Educational Progress, or NAEP, is used around the country to determine how states are doing compared to other schools in particular content areas. NAEP-released practice questions for teachers are used as they see fit. NAEP questions are useful to use in lessons and assessments to help students get comfortable with the format and learn strategies to advance their own learning. Next Generation Science Standards, which use the K-12 framework as a guide, developed a concept progression for different grades. They align some content standards or core ideas with the cross-cutting concepts. The developers of the NGSS did not identify a performance standard that aligns with the standards. However, the following 2 slides identify 2 NAEP items that do fit with standards in the K-12 framework for science education. Teachers may find other NAEP items that also help teach and assess the K-12 framework. Early primary students learn to construct and deconstruct matter in order to conceptualize that matter is not destroyed or created when something is broken apart into pieces or put back together. Released NAEP items in this presentation are aligned with one grade band, but many of them could fit with different grade bands to meet the standards. We had to pick one, but be creative. NAEP symbols on each question page are links to the original NAEP question on the NAEP website. The NAEP website includes useful information such as difficulty rating, to which grade it was administered, percentage of students who answered the question correctly, and the answer key. Why would a person be cooler on a hot sunny day in a light colored t-shirt and shorts than in a dark colored t-shirt and shorts made of the same material? Teachers may use this as part of a unit assessment, individual or partner work, or as part of a class discussion. This NAEP question addresses the concept of energy introduced to the system. Energy from the sun warms Earth's surface. Students can take it one step farther to understand that the sun warms other items on Earth's surface. How have we experienced this? Have you noticed any patterns in the day or year when Earth's surface is warmed more by the sun? Also look at matter. How are the shirts different? How is the matter different? Brainstorm descriptive words. This is an opportunity to design an experiment with your class to test ideas. Which is an example of melting? A. Flowing water making a rock smooth. B. A carrot becoming soft when cooked. C. Sugar mixed into tea making the tea sweet. D. Butter changing into liquid in a warm pan. K2 students learn that adding and subtracting heat from matter can change the state of matter. This question asks students to determine which example is that of melting. We may first approach the question as one of adding or subtracting heat. Do we have to add or subtract heat to melt something? Which example adds heat? How do you know this is an example of melting? This could be used as a simple writing or sketching prompt for a short assessment at the end of a unit or lesson. In grades 3 through 5, students learn matter is made of particles and energy can be transferred in various ways and between objects. Students observe the conservation of matter by tracking matter flows and cycles before and after processes and recognizing the total weight of substances does not change. Students in grades 3 through 5 focus on observing the flow of matter within a cycle and that the amount of matter does not change. Students in grades 3 through 5 focus on observing the flow of matter within a cycle and that the amount of matter does not change. This NAEP item requires students to identify the flow of energy within the flashlight. It would be ideal to have an actual model of a manual crank flashlight, but not necessary. It could also be done with a regular flashlight. You could then hold a class conversation surrounding how a crank flashlight is different. Review different types of energy and which parts of the flashlight deal with different types of energy. You could also work backwards. What is the last type of energy in this system? The light. A wire is cut into 4 pieces of different lengths. Each piece is stretched between two supports to the same tightness. Which of the pieces shown below would give the highest pitch if it were plucked in the middle? This NAEP item requires students to recognize that string length influences the pitch of the string when plucked. This question also provides opportunities to look at changes in matter. The parts of the string versus the whole string. Does this change the amount of matter? How do you know? How does stretching the string change the matter? What type of energy is added to the system to create a sound? Describe the flow of energy from beginning to end and how it creates a sound we can hear. In grades 6 through 8, students learn matter is conserved because atoms are conserved in physical and chemical processes. They also learn within a natural or designed system, the transfer of energy drives the motion and or cycling of matter. Energy may take different forms. Energy in fields, energy in thermal, energy of motion. The transfer of energy can be tracked as energy flows through a designed or natural system. Middle School Earth System Science 2 through 4 develop a model to describe the cycling of water through Earth systems driven by energy from the sun and the force of gravity. The big ideas here are conservation of matter, transfer of energy, cycles of matter and energy. Magma flowing out of an erupting volcano cools and solidifies to form igneous rock. Explain how the newly formed igneous rock can be transferred into sedimentary rock. This NAEP item asks students to make connections between hot-flowing lava and sedimentary rock. The rock cycle, or geologic cycle, is both a cycle of matter and energy. Follow the changes in matter from liquid lava to solid sedimentary rock. Follow the transfers in energy from liquid lava to a sedimentary rock. Which different geologic processes are involved in the cycle? Which types of energy are required for different processes? A class observes two demonstrations, water changing into steam and a piece of wood burning and producing smoke. A student concludes that both demonstrations must be examples of a chemical change because a gas is produced in each. Is the student's conclusion accurate? Explain your answer, referring to both demonstrations. Students must assess the conclusion made in the original NAEP item and support their answers with evidence. Some potential for demonstrations are as follows. Example 1. Water into steam. What must happen for liquid water to turn into steam? How does matter change when heat is added to turn liquid water into steam? What type of energy transfer is needed? Is this a chemical change? How can we prove and support your answer? Example 2. Burning wood into smoke. What happens to wood when it is burnt? What changes happen? How can we quantify the changes? What type of energy transfer must happen? Is this the same or different from the energy transfer needed to turn liquid water into steam? Is this a chemical change? How do you know? In grades 9 through 12, students learn that the total amount of energy and matter in closed systems is conserved. They can describe changes of energy and matter in a system in terms of energy and matter flows into, out of, and within that system. They also learn that energy cannot be created or destroyed. It only moves between one place and another place, between objects and or fields, or between systems. Energy drives the cycling matter between the systems. In nuclear processes, atoms are not conserved, but the total number of protons plus neutrons is conserved. In high school physical science 1 through 8, develop models to illustrate the changes in the composition of the nucleus of the atom and the energy released during the processes of fission, fusion, and radioactive decay. Big differences in high school for cross-cutting concept number 5, conservation of energy and matter within a cycle, introduction of nuclear processes in terms of conservation of subatomic particles. Which equation represents a chemical change? A, B, C, or D? This problem asks students to determine which chemical equation represents a chemical change. Go through each example and chart out the flows of matter and energy. What is exactly happening in each example? How do you know? What is the difference between a phase change and a chemical change? Use this to eliminate some of the options. What type of energy is required to start the chemical reaction? What happens to the energy at the end, the products of the chemical reaction? Which portion of the carbon cycle is driven directly by the energy from the sun? A. The formation of coal beneath rock layers. B. The release of carbon dioxide during volcanic eruptions. C. The emission of carbon dioxide from oil-burning power plants. Or D. The formation of sugars at Earth's surface. The NAEP item deals with the sun's energy relationship with the carbon cycle. Students must correctly identify which of the answers in an example of how the sun's energy drives the carbon cycle. How many different types of energy input are included in this model of the carbon cycle? Which parts of the carbon cycle do they impact? Can you follow the flows of energy? Narrow it down to the sun. Which part is impacted by the sun? Would it be able to function within the cycle if the sun's energy was not added? Here are 2 resources for teachers to get other perspectives on cross-cutting concepts number 5, energy and matter. NSTA also has a variety of digital and print resources and trainings available to educators that are grade level specific.